So take a minute, check, you see quiz 5 on the discussion course space. Do you all see it? Yes, no. Should be from 9:35 to 9:50. I think it's quiz 5. Okay, cool. Okay, so today we'll go over trig integrals. So I might go into secant tan too, because I believe your quiz on Tuesday is on that. And the second part of 7.2 is gone over Friday, but I don't really want to go over the stuff that's getting quizzed on the day of the quiz because I feel that's a bit too late. So I'm gonna probably go over the secant 10 part 2. Okay, so it's not really any different. So so our goal is to integrate trig functions. And the main things we will use is this common one, right? And then the double angle identities. So this is how I, remember it, but what we need is the opposite way. So we solve for cosine squared. So if you solve for cosine squared, you get this. And similarly, yeah. Okay, so for sine and cosine, there's really two cases. Case 1, at least 1 power of sine or cosine is odd. So you just need one of them to be odd. The other one could be like anything really. I should take that back. You need like yeah, it could be anything. So but now let's do the case where it's sine cubed x cosine to the 5th x. Yeah, so you could choose both either one, right? So what we do is we reduce that odd to 1 to the power 1 by changing sine to cosine or cosine to sine, depending on which one's odd. In this case, you could choose either, right? So the reason we can reduce odd to the power 1 is because we can always convert sines to cosines and cosines to sines via blue arrow. Yeah. But the thing is, we can only change multiples of 2, right? So that's sort of why we could move an odd number to 1, right? If it was 5, we could take out multiples of 2. So we take out like 4 to make 1. So let's just see that here in play, right? So this thing, right? Let's follow the rule. So we're going to treat this as the odd one. You could do the same for sine. You're going to get the same answer. But cosine to the 5th, so we reduce it to 1. How do we do that? Well, I could write this as cosine squared, cosine. Yeah. Now this is to the power 1, and then I change all the rest to sine. And the blue. So if sine squared plus cosine squared is 1, cosine squared is 1 minus sine squared, right? And really, the reason for this is this 1 here will be reserved for the du. The reason being is because derivative sine is cosine. And guess what? That's du now. So I have integral u cubed 1 minus u squared 1 minus u squared du. Right, and now it's simple, right? This is, I mean, not simple, but you could sort of see this is a much easier integral, right? U cubed, what is that? Minus 2u to the 5th plus u to the 7th, right? So let me just write the answer here. So I get u to the 4th over 4 minus 2u to the 6 over 6 plus u to the 8 over 8 plus c. So from here, right, we replace right back what u was. So sine to the 6x over 6. If you like, this is 1/3, but anyhow. Let me just rewrite this very nicely. Sine to the 6x, sine to the 8x. Yeah, is everyone clear on this? So, I mean, a lot of the trig integrals, I mean, integrating trig functions, it's just is you notice, right? It's just u sub. It's just some special u sub, aside from the second case, which I go over next. But okay. So what's the second case? If case 1 is at least 1 power is odd, the last case is just no powers are odd, right? So everything's even. So we have case 2, none are odd, right? So they're both even. So how do we do this? So, okay, can anyone tell me what goes wrong? Like, why can't we use the previous method? Like, just let u be sine or let u be cosine. Why is it a problem that everything's even? Anyone? Not necessarily, sort of, but okay, so let's say I want to let u be sine, yeah? Then I should convert that cosine squared to 1 minus sine squared. That is fine, but then I have nothing for du. Do you all see that? Like, I literally don't have a cosine x for du. When it was odd, it was nice because I could make that odd number an even number by taking out one copy, and I reserved that for du, and then I changed that even number to the other, to the like sine, cosine to sine, or like sine to cosine, right? Here I can't do that. Yeah, it's like I basically have nothing for du. That's sort of the issue here. So now here's how to understand the double angle formula. Can anyone tell me what the total power is here? Like if I have sine squared and cosine squared, what's like the total if I add the exponents, what do I get? What power is this? Yeah, this is power 4. Yeah. Okay, so let's see what the double angle does. Right here, this is power 2. I mean, this thing is easy. But cosine here is to the power 1, right? So what you see is we're going to exchange a power 2 for a power 1. We're going to keep reducing powers. Why is that? Well, cosine of 2x, I mean, that's still easy to integrate, right? Like the thing inside doesn't matter. It could be cosine of 10x for all I care. Like that's still easy to integrate, right? It's just when you have some power of cosine that makes it hard. So you see this double angle thing helps you reduce powers, right? You could change degree 2s to degree 1s, yeah? So what we're going to do is we're going to keep reducing the power using this double angle formula. So I'm going to replace that cosine squared and sine squared with everything here. So what you're going to see now is this is 1/2 1 minus cosine 2x. Now, hopefully you all see it, right? But you don't. So to make it simple, this is like a minus b, a plus b, right? So this is 1/4 integral 1 minus cosine squared 2x dx. Yeah. So it's okay. Can anyone tell me what the highest exponent is here? Like what's the biggest power you see in this integral here? 2. Yeah, good. Power 2. So you see, we just reduced the power by using the double angle formula. And hopefully you see what's next. We reduce it again. Because again, it's easy to integrate cosine, right? It's hard to integrate cosine to some power. So what we're going to do is we're going to keep reducing powers. So, but this one's easy to integrate, right? It's just 1/4 x minus 1/4 integral. Okay, so let's figure out how to reduce this. So we're going to make this from power 2 to power 1 now. So bear with me. So let me just erase this now. So does everyone agree that this equation holds for all x? In particular, it holds if I replace x with 2x. Yeah, I mean, it's still true, right? This identity still holds. So I don't know why I wrote that. 1 plus. So I replace x with 2x. Does everyone see what I did? Like all I did was just replace x with 2x. Then boom, voila, we're done. So cosine squared of 2x is 1/2 1 plus cosine of 4x. And so let's just rewrite it. So this is what did I just say? It was it 1/2? Did I miss something? Yeah, I think it was 1/2 1 plus cosine of 4x, right? So at this point, this is pretty simple, right? Minus integral. How about I do plus and then minus 1/8 minus 1/4 cosine of 4x. Yeah. Now, do you all agree this is easy, right? You can integrate each of these terms, right? This thing's to the power 1 now. Now it becomes very simple, right? It's so what is that? So the first one, let me just go faster. So integral of this is just negative 1/8 x. So if I add 1/4, I just get positive 1/8 x. Subtract, and then integral of 1/4 cosine of 4x should be, I mean, that will give you, sorry. No, 1/8. Sorry about that. There should be 1/8. This should be 1/32 cosine of, or sine of 4x. Yeah. Everyone good? Or do you need me to, I mean, the last class asked me how to integrate cosine of 4x. But do you all know how to integrate cosine of 4x? Like, when it's not just x inside, but it's a 4x inside. Do you all know how to do that? No, I mean, yeah, but like, I mean, like the official way is just u is 4x. I'll just do it. So 1/4 du is dx. So this is integral cosine of u, and then 1/4 du, and then this is 1/4 sine u. C, replace u. Yeah. If you like, you just do u sub, right? You just u sub the 4x. So if it was sine 4x, so you mean integral of sine 4x? If it was integral of sine 4x, would it be, yeah, exactly. Yeah. That's right. It should be negative 1/4 cosine of 4x. Okay, everyone clear? So does everyone understand like the point of double? Because I feel like some people just tell you to use it, but like you don't know what you're doing. The point is you're reducing powers. Yeah. So I'm just gonna go over the secant cases because I mean they're not they're pretty much the same. There's nothing new to it. It's just more trig. So let's go back to here. Why did we care that at least one power was odd again? We reserve for the du, right? So if I let u be sine or u be cosine, we reserve that for the du part for that extra copy, right? And then that would make all the other terms even. So same thing for secant and trig, secant and tan. Yeah, so we have this identity. So case 1, power of secant is even. Then save a copy of secant squared. So why did I do that? What is derivative of tangent? Can anyone tell me? If I'm going to let u be tangent, what is du? What is derivative of tangent? Yeah, exactly. So that's exactly why I do this, right? Again, it's the same idea as the u sub for the sine and the odd case, when at least one is odd for sine and cosine. I'm reserving a copy of sine or cosine for the du part, right? Because derivative of sine or derivative of cosine is just one or the other. Here it's a bit different, right? Because derivative of tan is just not secant, it's secant squared. So instead of reserving a copy of secant, I need to reserve a copy of secant squared. And then convert all others to tangent. Right? So if I had, say, secant to the 4th x tangent to the 6x dx, right? So I save a copy of secant squared. So let's make the secant squared, right? And now I change, I mean, I keep one copy. So let's change this one. And using this formula here, secant squared is 1 plus tangent squared. sorry, I should have wrote the dx and secant together, but this is a 6, so sorry. Okay, so yeah, you're done. Let u be tan, du is secant squared x dx. So here, right, this part's du, and then I get integral 1 plus u squared u to the 6 du. du. I mean, at this point, it's simple, right? It's, and then what was u? U was tangent, so tangent to the 7x, tangent to the 9x over 9 plus c. Everyone clear? It's pretty much the same idea as the sine and cosine odd case. Like you're just reserving a copy of whatever the du is. Yeah. So let's continue. So case 2, so if tangent, so the case 1 was some power, the secant power of secant is even. The second is a bit weird, but the tangent power is odd power. Yeah, and we have like say secant is of power. So there is a copy of secant. So secant could be anything. It just needs to be there. Yeah. So what's the idea here? So if I decide to let u be secant, what is derivative of secant? Oh, math 2a. What is derivative of secant? Yeah. So now you see why tan needs to be odd, right? So we save a copy of secant x tan x. So when I remove a copy of tan, this has a copy of tan, right? So if I remove a copy of tan, tangent, since tangent is odd, it will become even. And then I could change all even powers to secant, right? That's pretty much the idea. So, and convert all other copies of tangent to secant. Yeah, so I mean, secant could be anything, right? So if tan is odd again, we keep a copy of secant x tan x. So if I keep a copy, this becomes this, right? And then just follow it, right? Convert all other copies of tangent to secant. So this is, I'll go slow. Tan squared x, tan squared x. So if secant squared x is 1 plus tangent squared, then tangent squared x is 1 minus secant squared x, right? Or sorry, secant squared x minus 1. Yeah. So the idea of secant tangent is the exact same as the idea of like cosine and sine odd case. That's sort of why I just go over it anyways. So let u be secant x, du is secant x tan x dx. So this is du, and I get integral u squared minus 1, u squared minus 1 du. Yeah. So what is that? U to the 4th minus u squared times u squared minus 1 du. I did not prepare for the algebra, sorry. Or else I would have made the numbers easier. Plus u squared du. I'll just write the answer here. So what is that? U to the 7 over 7 minus 2u to the 5th over 5 plus u cubed over 3 plus c, and then just replace what u was, right? U was secant. So secant to the 7x. And that should be plus the thing I just assumed over was a 3. Is everyone clear on this? Yes? No? Nothing too hard. So case 1 was secant was even, power of secant was, case 2 is power of tangent is odd. So let me just say the rest is on case by case basis. Let me just sort of, convince you that it's hard. The rest are case by case basis. So let me just say this, even this thing, yeah, this thing is hard. I know you won't believe it, but like this thing is actually harder than like secant cube times 10 to the 5th, like integrating just secant, right? Because the case 1 was secant, power of secant was even, right? So here power of secant is odd. So even something like this is like, extremely hard to do. So let me just convince you, like some mathematician in the past realized you can multiply by this. Right, so no, here I'm not changing the question, right? Because if I divide something by itself, I'm just multiplying by 1. So it doesn't change anything, right? Do you all agree? Like if I like multiplying by 2 over 2 does not change anything. So this is integral secant squared x plus secant x tan x. Right, if I distribute in the secant tan x. Right, so now if I let u be secant x plus tan x, something magical happens. Because du is derivative of secant is secant x tan x. Derivative of tangent is secant squared. And guess what? This is exactly du. And this is exactly u. So this is just integral 1 over u du. And we all know what this is, right? And then replacing back u. So this is actually the integral of tan. It's natural log of secant plus tan x plus c. As you can see, it's highly it's not easy, right? like nobody in their right minds would think of to multiply by this. So yeah, so let me just say like all the rest, maybe like tan for tangent, right? Tangent, you probably tangent alone, you just do u sub, right? Tan cubed, you need some special trick. And then so on and so forth. It's like case by case. But yeah. Any questions so far? At least, and that's all I have. But any questions on trig integrals? So for this, I suggest you just memorize it. Like, no. Okay. So maybe turn your camera on. You have like 5 seconds. I mean, not 5 seconds. 5 minutes till the quiz. You could 5 minutes. You have like 5 minutes to study.